Making sense of fractions. In this lesson we'll look at comparing fractions, what mixed numbers and improper fractions are, adding and subtracting fractions, and multiplying and dividing fractions. A fraction is a part of a whole. The circle is divided into 12 sectors, so each sector is 1/12 of the whole circle. There are 2 red sectors, so that represents 2/12. They can be combined into one bigger sector. We will need 6 of those to fill the circle, so each one of those is 1/6 of the circle. We say that 2/12 and 1/6 are equivalent fractions. They're the same size. What fraction is orange and what is its equivalent fraction? There are 3 orange sectors, so that represents 3/12. When we combine them into one bigger sector, we can see that we need 4 of those to fill the circle, so they represent 1/4. The number on the top of the fraction is called the numerator, and the number at the bottom of the fraction is called the denominator. The bar has been divided into sixths and thirds. 4/6 are shaded in blue, and that is equivalent to 2/3. We can do that simply by dividing the numerator and the denominator by the same number, in this case 2. We say that we're cancelling down 4/6 to 2/3. Sometimes we need to go the opposite way around. So starting with 2/3, we can see that that's equivalent to 4/6, and we get that by multiplying both the numerator and the denominator by the same number, 2 in this case. A fraction wall can help us find equivalent fractions. For example, the fraction 1/2 is equivalent to 2/4 or 4/8, 3/6 or 6/12. Whereas the fraction 1/3 is equivalent to 2/6, 4/12 or 3/9. Mixed numbers and improper fractions are different ways of writing numbers that are larger than 1. A mixed number has a whole part and a fractional part. An improper fraction has a numerator that is larger than its denominator. These are different ways of writing the same quantity. In this case, these two fractions are equal. To write a mixed number as an improper fraction, we write the 1 as 5/5. To get that, we do 1 times 5, and then we add the 2 to get a total of 7/5. We can only add and subtract fractions if they have the same denominator so that the parts are the same size. So we need to express both fractions with a common denominator. For example, adding 1/2 and 1/3, we'll need to get the same denominator, that is 6, something that both 2 and 3 will go into. The 2 needs to be multiplied by 3, and so we need to multiply the numerator by 3 as well. Similarly, the 3 needs to be multiplied by 2 to get a common denominator of 6, and so we multiply the numerator by 2. When we multiply by 3 over 3 or 2 over 2, we're really multiplying by 1, so we're not changing the size of those fractions. We're getting equivalent fractions. So 1/2 is the same as 3/6, and 1/3 is the same as 2/6. Adding those parts together, 3/6 and 2/6, will give us 5/6. We may be tempted to multiply the two denominators, and that'll give us a common denominator, but not necessarily the lowest. For example, if we have halves and sixths, We're looking for a common denominator between 2 and 6. 12 is such a common denominator, but it's not the smallest. 6 will be the smallest. The arithmetic always works out easiest if we use the smallest common denominator. So we need to multiply the 2 by 3 to get sixths, and of course we have to multiply the 1 by 3 as well. So that will give us 3 sixths minus 1 sixth is 2 sixths. Now we don't leave our answer there because we can cancel down and simplify that fraction. 2 into 2 goes once, and 2 into 6 goes 3. So our answer is 1/3. Here we are adding sixths and tenths. We can find a common denominator between 6 and 10 by listing all the multiples of 6. 6, 12, 18, that's the 6 times tables, and the multiples of 10, 10, 20, 30, 40. And we are looking for the smallest common number there, and that will be 30. Now note that we could have got a common denominator by doing 6 times 10 is 60, but that is not the lowest. So now we have to change our denominators to 30s. The 6 needs to be multiplied by 5, so we multiply the numerator in 1/6 by 5, and the 3/10 we're multiplying by 3 over 3. So that gives us 5 over 30 plus 9 over 30, which of course gives us 14 over 30. And once again, we don't leave our answer like that. We do simplify it by dividing both that numerator and the denominator by 2. We cancel it down to 7 over 15. The recipe calls for half a cup of sugar. If you want to make half quantities, how much sugar do you need? Well, to answer that, we need to work out what a half of a half is. And here we've represented a half of the strip. And if we get half of that again, you can see that what we have is a quarter. Let's look at multiplication in a different way. Dividing the square into 5 sections, we have fifths. There we have 1/5, and we want a half of that. So we cut it in half, and then we are left with 1/10. Let's see how we can do multiplication without a diagram. We'll write our fraction with the numerators on the line. They represent multiplication numbers, and the denominators below the line, they are divide by numbers. We can see that we are multiplying by 5 and dividing by 5, and they will undo one another, so we can cancel those two out. Similarly, we can divide 2 into 2 goes once, and 2 into 6 goes 3 times. What we're saying there is multiplying by 2 and then dividing by 6 is the same as simply dividing by 3. Multiplying those numerators together, we've got 1, and the denominators is a 3 there. So our answer is 1/3. Let's move on to division now. Here we want to find the number of halves and 3 wholes. Dividing into halves there, we can see that each whole contains 2 halves. So in 3 wholes we will have 6 halves altogether. So 3 divided by a half, how many halves in 3? That is 6. Dividing by the half was really the same as multiplying that 3 by 2, which is of course 6. So dividing by a fraction is the same as multiplying by the reciprocal of that fraction, that is the fraction turned upside down. Let's look at another example. How many thirds are there in 2 wholes? Dividing into thirds, there we can see that in each whole there are 3 thirds. So therefore there are 6 thirds in 2 wholes. That is, 2 divided by a third is 6, which is really the same as 2 multiplied by 3, which of course is 6. So again, we can see that to divide by that fraction 1/3, we really multiply by the reciprocal of that fraction, that is 3/1. What about 2 divided by 2/3? We saw that 2 divided by 1/3 was 6. Now 2/3 is really twice as big as 1/3, so half as many will fit in. That is, the answer will be 6 divided by 2, which is 3. We can see we have 1 2/3 there, there's another 2/3 and a third 2/3. So our answer is definitely 3. So 2 divided by 2/3 really worked out to be the same as 2 multiplied by 3/2, again multiplying by the reciprocal. Our 2's cancel out and we're left with just 3 as our answer. So to divide by a fraction, once again we simply multiply by the reciprocal. Recapping, we saw that equivalent fractions or equal fractions can be obtained by multiplying or dividing the numerator and the denominator by the same number. To add and subtract fractions, we first have to find a common denominator. When we're multiplying fractions, we start off by cancelling down, that is dividing the numerator and the denominator by the same number, and then we multiply the numerators together, and we then multiply the denominators together. And to divide by a fraction, we multiply by the reciprocal.